Today I will discuss about the entity relationship set. What is entity? What is attribute? Types of its attribute and relationship. Here diagram representation, generalization, specialization, inheritance, and cost 12 rules. Okay, what is entity? Entity can be a real world object. Entity can be a real world object, either animate or inanimate, that can be easily identifiable. Means entity can be a real world object which has its independent existence, which of its has independent existence. Example, suppose school database which contains the different tables, means relations, table otherwise known as relations, that is teacher, student, classes, course, offered, that is the entity. And what is entity set? An entity set is a collection of similar types of entity. Entity set is a collection of similar types of entities. An entity set may contain entities with attributes sharing similar values. Means suppose an entity teacher is the entity which contains the teacher ID, name, course, which subject that teacher teaches, and all these things, the three attributes included in that entity, that is the entity, and entire same type of, suppose the entity set is the teaching staff. Teaching staff is the entity set which contains the all the teaching relations, that is called entity sets. Then attribute represents by means of their properties called attributes. Attributes means to define the property of its, that is called attributes. All attributes have the values. When student contains the name, class, and age. Name, class, age is the attribute of the student relation. Name, class, age. Name, field otherwise known as entity. Sorry, field otherwise known as attribute. The student is a entity which contains the attributes name, class, and age. This is the example of attributes, and different types of attributes in relational database management system. First one is simple attribute. Simple attribute contains the atomic value. Atomic value means which cannot be divided. The value of that attribute cannot be divided. Means the phone number of a person that is contain 10 digit, that cannot be divided. Suppose this is the example of the simple attribute. Then composite attribute. Composite attribute, this attribute, the value of this attribute can be divided, that is called composite attribute. The value of the attribute or the domain of the attribute can be divided. Means suppose address is an attribute which can be divided into number. Address contains the art, post, dist, via, pin, all these things can be divided, that is called composite attribute. The name also another example of composite attribute. First name, last name, this is the composite attribute. Then another one is derived attribute. Derived attribute is that the value of this attribute can be derived from other field or other attribute. The value of this attribute depends upon the other attributes. The value of this attribute derived from other attribute, that is called the derived attribute. Example, suppose average salary in a department should not be saved directly in the database. Instead, it can be derived. Suppose age is the another example of the attribute, derived attribute, which derived from the date of birth. That is the derived attribute. Then next one is the single value attribute. Single value attribute contains only the single value. That is the example of social security number, the student ID, roll number. This is the example of single value attribute. Multi-value attribute may contain more than one value. Suppose the phone number of a person having a single person maybe contain two or three phone numbers, and the address, mailing address, and the residence address, office address. This is the example of the multi-value attribute. Then what is relationship? The relationship is that is the association between entities. The association between entities, that is called relationship. What is the relation between the entities? That is called relationship. Means suppose a student and teacher. Student is an entity and another the teacher is the another entity. What is the relation between them? The teacher teaches student. Teaches is the relationship between the student and teacher. That is the association between the or number of entities, that is called the relationship. Example here, that is the employee works at department. Employee is one entity and department is another entity. Works at is the relationship among employee and department. Then student enrolls in a course. Another example is that the students enrolls in a course. Course is one entity and a student is another entity. And the relationship among the entity student and course is called enrolls. Then relationship set. A set of relationship of similar type is called relationship set. A set of relationship of similar type is called a relationship set. Like entities, a relationship two can have attributes. These attributes are called descriptive attributes. A relationship two can have attributes. These attributes are called descriptive. Suppose the relationship, the entities, like entities, the relationship having the number of entities, number of attributes, having the number of attributes more than enough attribute, that is called descriptive attribute, which details describe the relationship, that is called descriptive attributes. Then mapping cardinality. Mapping cardinality is that it defines the number of entities in one entity set which can be associated with the number of entities of other set via relationship set. Cardinality defines the number of entities. How many number of entities are related with a relationship set, that is called cardinality. The number of entities set associated with the relationship set is called the cardinality. There are different types of mapping cardinality. One is one to one, one to many, many to one, and many to many. Okay. Then one to one is the entity set. Suppose entity set A and entity set another, suppose by mistake here written, that is the entity set B. Here the one to one means the one attribute, one value of this entity set should be connected or should be associated with the one entity of the entity set B. That is called one to one cardinal mapping cardinal. One to many, at most, at least one attribute of entity set A associated with the number of attributes of the entity set B. That is called one to many relation or cardinal mapping cardinality. Then many to many, many to one means the number of attribute of entity set A should be associated with at least one attribute of the entity set B. One attribute of the entity set B. That is many to one. Then many to many means the number of attributes of entity set A should be associated with the number of entities of entity set of B. Number of attribute of the entity set B. That is to many relation. The number of notations are used in ER diagram, and these are called the diagrammatic symbol of the ER entity relationship system. What is an ER diagram? Entity relationship diagram. This is the visual representation of different entities within a system and how they relate to each other. The entity relationship diagram is that which represents the different entities and what are the relations between them, that is graphically represented, that is called the entity relationship diagram. The number of symbols or notations are used in entity relationship diagram. First one is the entity. The rectangle shape is used for entity. Attribute is the oval shape. Then relationship is the diamond shape used for relationship. Used for relationship. Okay. Weak entity set. Weak entity set symbol of the weak entity is a double layer of the rectangle, double line of the rectangle. That is weak entity set. Then multi-value, the double line of the oval shape. Weak relationship, double line of the diamond shape. Then weak entity set. What is weak entity set? Entity? Weak entity is that which has no sufficient attribute for make a key. Which has no sufficient attribute to make a key. The what is key? Key is a attribute which uniquely identifies the record from a relation. That is key. Which relation has no sufficient attribute to uniquely identify the record in a relation, that is called weak entity. Then this is the ER diagram representation. Here is entity, teacher, student and classes. Entity, what are the, to represent a diagram, how to draw a ER diagram? First you have to decide the number of entity in that problem. After identify the entity, then define the attribute of each entity. Define the attribute of each entity. Here the entity are teacher, student, classes. Then after defining the entity, then find out the attribute of each entity. What are the attributes may contain a entity? Then attributes, suppose student is a entity which has the three attributes. Then name, birth date and roll number. Three attribute of the student. Okay. Then ER diagram representation, composite eye. Composite eye means already we have discussed what is composite eye attribute. The value of this attribute can be divided. That is called composite eye attribute. Then student contain the name, birth date and roll number. Here the name is again divided into first name and last name, so that the name attribute is the composite attribute which can be divided into two parts. One is first name and last name. Then multi-value attribute means that the attribute contain more than one value, that is multi-value attribute. Here the student, birth date, roll number, phone number is another attribute included in the entity student. Then name, this is the name is a composite attribute and phone number is a multi-value attribute which contain more than one value. Then derived attribute, the value of this attribute derived from another attribute or depends on the another attribute. Then student, entity contain the name is the composite attribute and phone number is the multi-value attribute and age is the derived attribute. The derived attribute always enclosed within the dotted circle, dotted oval shape, dotted oval shape. Alright, dotted oval shape that is included the weak entity set. Also, it is called weak entity set. Entity value. The age is a derived attribute which depends on the value of birth date. Means the value of age is derived from the birth date attribute. Then here diagram represents relationship and binary relationship and cardinality. When two entities relationship, the association among the entities is called relationship. When binary relationship and cardinality, when two entities participate in a relation, then it is called binary relationship. Means student, teacher, teacher, student. Teacher is the entity, one entity, and student is another entity. Teachers is the relationship. Here the binary relationship means these two entities are participate in the relationship is teachers. Cardinality is the number of instances of an entity from a relation that can be associated with the relation. Cardinality means how many relations are participate in the relationship. How many relations or how many entities are participate in the relationship is called cardinality. Suppose binary means two, the cardinality is two. Number of instances of entity from a relation that can be associated with the relation, that is called cardinality. Here the representation one to one relation, then entity, then example of one to one person passport. One person has one passport. Student roll number. This is the example of one to one relationship. Then one to many, mother children is one to many, and student address is one to many relation. Mother one and number of children. Student may be staying at different places, so that the address of the student and address is the one to many relationship. Then many to one, students teacher. One teacher can teach us number of students. One teacher can teach us number of students, so that the student's teacher is the many to one relation. Many to one, books and author also another example. Many to one, number of books are one author can be write number of books. That is many to one. Participation constraint. Constraint means that is the rule or restriction of a relation, that is called constraint. The restriction of that of a particular relation, that is called constraint. Participation constraint means when the entity participate in a relation, what are the constraint, what are the rule for that? That is called the participation constraint. There are two types of participation constraint. One is total participation, another one is partial participation. Total participation, the symbolically represented in double line, and partial participation is single line. This is the symbolically representation of the participation constraint. Then participation constraint, total participation means the entity of, this is the relationship P, and suppose this is the entity A and entity B. Here the entity A are totally participated in the relationship P. The example of this, that is the loan account of the customers in a bank. Loan account of the customer in the bank. The loan customer is totally participate totally dependent on the bank for the loan, that is the total participation. But the customer of the bank may take the loan or may not take the loan. That is the customer relation with the bank, that is the partial participation. All the customers of the bank, some customers are interested, are interested to take the loan. Means some customer already took the loan. That customer is totally dependent or totally participated in the relationship fee. But the customer of the bank, they don't take any loan, but the customer of the bank, that is called the partial participation. How to draw a year diagram? Some of the points are there to draw a year diagram. First, identify all the entities which rule to draw a year diagram. When the question come in front of you or in your exam, at that time, first read the question and find out to draw a year diagram. Before draw a year diagram, first find out all the entities in the questions. After find out the entities, then that entity should be enclosed within the rectangles. That entity should be enclosed in the rectangle and name them properly. Write the name of that entity. Suppose teacher, student. This is the teacher is an entity and student is another entity. Suppose two entity, identify two entities and that entity should be enclosed within the rectangle and name mentioned in that rectangle. Then second point of that, after find out the entities or identify all entities, then identify the attributes of each entities. Find out the attributes of each entities. Find out the attributes, suppose teacher, teacher ID, teacher specialization, teacher name. Student is another entity which contains student roll number, student name, and the course or which course the student is admitted. Okay. Then find out the relation between them. Find out the relation between them. Means the number of attribute, what are the relation among them to identify the relationship. Once relationship, after defining the relationship, then the mapping cardinality, one to many, many to many, one to one, many to one, what type of relationship between them to define the mapping cardinality. Clearly, please remember these points when before you draw the ER diagram, you have to follow this rule, then you can do a better ER diagram. First, find out the entities. Second, find out the attributes of each entities. Then, what are the relation between what are the relation among the entities? After defining all this with the proper symbol, with the proper symbol. After that, then mention the mapping cardinality one to one, one to many, many to many. This type of relationship among them to define that. After that, then participation. Define the participation. Totally participate or partially participate. This should be mentioned in the ER diagram. Once define this, another thing is that before draw ER diagram, first mention the identify all the entities, then write the heading entity sets. What are the entity set? Define the entity name pointwise. Then second, what are the attributes of that? Each entity, suppose student, roll number, then define, right? Student heading is student and number of attribute of that students. And clearly mention this. Then what are the relation among them? Also relationship set the heading, write the relationship, then point the number of relationship among them. After this, then start the or draw the diagram. Okay, this is the ER diagram. Then generalization and specialization. Generalization and specialization. The ER model has the power of expressing database entities in a conceptual hierarchical manner. As the hierarchy goes up, it generalizes the views of entities, and as we go deep in the hierarchy, it gives us a detail of every entity included. Going up in the structure is called generalization, reverse is called specialization. This is the generalization. Means this is the, in case of generalization, first you have to mention the subclasses of this. Suppose teaching staff having the office staff, the subclass of the office staff, teaching staff, non-teaching staff. Teaching staff is regular teacher or guest lecturer. Regular lecturer, guest lecturer. Teaching, contractual, permanent. In this case, the in generalization case, you have to first define the subclasses. Subclasses means first define the regular lecturer, guest lecturer, or contractual lecturer. Regular employee, contractual employee. Then after that, then define the teaching staff, non-teaching staff. Then that is combined to mm, the office staff. This is the first sub, define the subclass, then superclass. This is the generalization. And specialization is the reverse of this. Means first you have to define the superclass, then subclass. Here the generalization, sparrow, pigeon and peacock. This is the subclass sparrow, pigeon and peacock is the subclass, and it included under the birds. Included under the superclass birds. This is the generalization. And go to the specialization. Here the superclass, first define the superclass person. That person may be divided into student and teacher, and student, regular student and ex-regular student. Again define student may be defined as regular student and irregular student, or the distance student, distance course student, and teacher may be regular teacher and contractual teacher. This is the specialization. The one thing is remembered, those in case of generalization, first subclass is defined, but in case of specialization, first superclass is defined. This is the main difference between generalization and specialization. The difference between generalization and specialization, what are the difference between the this? First one is generalization works in the bottom up approach, and specialization works in top down approach. In generalization, size of schema gets reduced. First define the subclasses, then slowly the size of the schema is reduced. But in case of specialization, the size of schema is the actual design of the database. The design of the database is called schema. In specialization, the size of schema gets increased. Means the superclass is first defined, then define the subclasses so that the schema is increased. Generalization is normally applied to group of entities. Generalization is normally applied into group of entities. In specialization, it is a single entity. Single means first person is a single entity that divide the student and teacher. But in case of generalization, first parrot, peacock, and crow, that is combined into a single entity. There is no inheritance in generalization. In case of generalization, there is no inheritance. What is inheritance? Inheritance, you know what is inheritance? Hello? Hello? My voice is audible? Hello? 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 My voice is audible or not? There is no inheritance in generalization. Inheritance means the inheritance is a property. It's object oriented database or object oriented language which the subclasses access or the attribute of the superclasses. Also, that is the inheritance property. The characteristics of one class is inherited in the inner class. But in case of specialization, there is no inheritance. Sorry, in specialization, there is inheritance, but in case of generalization, there is no inheritance. Generalization can be defined as a process of creating grouping from various entities set. And specialization can be defined as a process of creating subgrouping within an entity set. These are the difference between the generalization and specialization. Key is a attribute. Key is a attribute through which we can access the records from a database or from a relation uniquely. That is called key. There are different types of key: candidate key, primary key, super key, composite key, secondary key, foreign key. Different types of key in relational database management system. First one is the candidate key. First, you know what is primary key. The primary key is selected from one of the candidate key and becomes to identify the key of a table. It can uniquely identify any data row of the table. Means the primary key is a attribute through which we can access the records from a table. Uniquely access the record from a table, that is called primary key. Then super key. Super key is the superset of primary key. Means the combination of the suppose student database, student entity contain the roll number, name and mark. Here the primary key is the roll number. Means through which we can uniquely identify the records from a relation. If you take the primary key as a name, the maybe two or three person has same name, same title, but roll number always unique. So you can identify the records from a relation uniquely that using the prime roll number. So that always choose a attribute through which you can uniquely identify the records or uniquely access the record from a relation, that is called primary key. Super key is the superset of primary key. The super key contains a set of attributes including the primary key which can uniquely identify any data row in the table or any record in the table. That is the super key. The combination of key, the more than one attribute are combined to define as a key, that is called super key. Then candidate key. Candidate key is the minimal of the super key. Candidate key is the minimal of the super key. Then composite key. If any single attribute of a table is not capable of being the key, that is, it cannot identify a row uniquely, then we can combine two or more attributes to form a key. This is known as composite key. Then secondary key. Only one of the candidate key is selected as a primary key. The rest of them are known as the secondary key. Suppose super key. Super key contains the three attributes: the roll number, suppose roll number, and then the name, and then mark. In this key, the roll number is the primary key and other key are secondary key. Then foreign key. Foreign key is an attribute value in a table that acts as the primary key in another table. Hence, the foreign key is useful in linking together two tables. Data should be entered in the foreign key column with great care, as wrongly entered data can invalidate the relationship between the two tables. Means foreign key is that the primary key of other relation is used the used as the key in a new relation. That in new relation that is called as foreign key. Suppose roll number, name, and mark is a relation, a student relation, and then department is another relation which contain the department id and department name. Suppose you want to access the record of a student who has studied in a particular department. In that case, you combine the relation. So the department ID is the primary key of the department relation and roll number is the primary key of the student relation. In that case, you combine this relation. So use the department ID in the student relation. In this case, the department ID is the foreign key for the student relation, but roll number is the primary key of the student relation. This is the key. Then constant. Every relation has some conditions that must hold for it to be a valid relation. These conditions are called relational integrity constant. There are three main integrity constant. One is key constant, domain constant, referential integrity constant. Okay, the three types of constant. Constant is the restriction or rule which contain, which hold for it to be a valid relation. Then one is key constant, domain constant, and referential integrity constant. Key constant is that there must be at least one minimal subset of attributes in the relation which can identify a tuple uniquely. This minimal subset of attributes is called key for that relation. If there are more than one such minimal subset, these are called candidate key. Key constant is that key of the key of a relation should be contain a unique value. That is the key constant. The primary key of a relation should be contain unique value. That is the key constant. By mistake, the data entry operator may be used the roll number of a student 20, 25, 28, maybe repeatedly use the 25 two times. In that case, that at that time a message will come. The primary key of the relation should not be duplicated. The value of the primary key of a relation should not be duplicated. That is the key constant. Key constraints force that in a relation with a key attribute, no two tuples can have an identical value for the key attributes. And a key attribute cannot have null values. The two constant of the key constant, the value of the attribute should not be duplicated. And that value should not be null. Means that should not be blank. This is the key constraint. Domain constraint. Attributes have specific values in real world scenario. For example, age can only be a positive integer. Domain value means what type of value a particular attribute can contain. That is the domain constraint. Suppose name always contain the character type value, but by mistake you will try to put the integer value. That is the domain constraint. The same constant have been tried to employ on the attributes of a relation. Every attribute is bound to have a specific range of values. For example, age cannot be less than 0 and telephone number cannot contain digit outside 0 to 9. This is called the domain constraint. A referential integrity constraint. A referential integrity constraint work on the concept of foreign keys. A foreign key is a key attribute of a relation that can be referred in other relation. Referential integrity constant states that if a relation refers to a key attribute of a different or same relation, then that key element must exist. Suppose referential integrity constant is that suppose uh, use the department ID in student relation. That is the foreign key. When you access the value of that foreign key, that attribute should be present in other relation and that attribute contains some value. That is called referential integrity constraint. Then chord rules. Chord rules the to maintain the database, proper database, the chord rules are used. First one is the information rule. This is more important. That is the first rule of the chords rule. One is information rule. The data stored in a database, may it be user data or metadata, must be a value of some table cells. Everything in database must be stored in a table format. Information rule means when the data stored in the database, that data may be user data, that may be a metadata. Metadata means the data inside the data. It's collecting the data from different sources and stored in a data dictionary, that is metadata. That should be stored in the database in table format. Guaranteed access rule. A second rule of the code is called the guaranteed access rule. Every single data element is guaranteed to be accessible logically with a combination of table name, primary key, and attribute name. No other means such that pointer can be used to access. Means to access the data from a database using the primary key or the name of the attribute, table name, primary key, and primary key and the attribute, which attribute you want to access. Means suppose a student database contains the student name, student uh, roll number and mark. The guaranteed access rule is that when you access the value from the student database, at that time you have to mention the student table name means student and primary key roll number and other attribute which you want to access, maybe roll number, name, maybe mark. Then third rule of the code is systematic treatment of null values. Systematic treatment of null values. The null values in database must be given in a systematic and uniform treatment. The null values in a database must be given in systematic and uniform treatment. This is very important rule because null can be interpreted as one of the following: data is missing, data is not known, or data is not applicable. Means suppose a field or suppose a attribute defined as a null means that does not mean zero. Means the data is missing, maybe data is not available, or data is not known, unknown data, and data is not applicable. Maybe that is not applicable for that table. This is the null means that. Then fourth rule of the code is called active online catalog. The structured description of the entire database must be stored in an online catalog known as data dictionary, which can be accessed by authorized users. Users can use the same query language to access the catalog which they use to access the database itself. In data dictionary, different types of data. Online means the distributed database system are used in case the number of databases are available in different geographical area. When a user accesses a particular data from a data dictionary, at that time that data may be stored in your location, may be stored in another location, but you are a authorized users, you can use the same type of query language which is used by that database to access that data. That is the active online catalog. Then fifth rule, comprehensive data sub language rule. A database can only be accessed using a language having linear syntax that supports data definition, data manipulation, and transaction management operation. This language can be used directly or by means of some applications. If the database allows access to data without any help of this language, then it is considered as a violation. Means compressing data sub-language means you can, when you access the data from a database, at that time you have to use the data manipulation, transaction management, or data definition language to access the data. If you don't use this language, then this is violate the rule of the courts. Then sixth rule of the court, view updating rule. All the views of database which can theoretically be updated must also be updatable by the system. View updating rules means once the database is updated, then it is applicable for the view. Otherwise, before updation, it will not keep in the data dictionary for the view. Then seventh rule, high level insert, update and delete rule. High level insert, update and delete rule means a database must support high level insertion, updation and deletion. This must not be limited to a single row. That is, it must also support union, intersection and minus operation to yield sets of data records. So at a time, to union, the number of tables are united, and union using the union operation, using the intersection operation or minus operation, and use the high level of insertion, updation and deletion rule so that it can be updated, deleted or inserted. Eighth rule, physical data independence. Already you know what is independence in previous class. Then data stored in a database must be independent of the application that access the database. Any change in physical structure of database must not have any impact on how the data is being accessed by external application. Physical data independence means there is any change in physical structure of the database that cannot be affect the external view or view level, that is called the physical data independence. Then ninth rule is the logical data independence. The logical data in a database must be independent of its user view. Any change in logical data must not affect the application using it. For example, if two tables are merged or one is split into two different tables, there should be no impact or change on the user application. This is one of the most difficult rule to apply. Logical data independent means to one level. If any change in one level, that does not affect the physical. If any change in logical level, that does not affect in the physical level. Tenth rule, integrity independence. A database must be independent of the application that uses it. All its integrity constraints can be independently modified without the need of any change in the application. This rule makes a database independent of the front-end application and its interface. Means integrity independence means in a distributed database system, the number of database are stored in different geographical area. Maybe that database contain the different interfaces, different applications. If there is dependency, it is very difficult to access. So that integrity independence means you can access and there is a converter to convert your application. Front-end application are there which are support to access that data. That is the integrity independence. 11th rule, distribution independence. The end user must not be able to see that the data is distributed over various locations. Users should always get the impression that the data is located at one site only. This rule has been regarded as the foundation of distributed database system. Means distribution independence means when the user access some data, the data is act as a local area. The data stored act as a stored in local area, that there is no mention where the data is extracted. That is the distribution independence. Non subversion rule. Last and 12th rule of Scott's non-subversion rule. If a system has an interface that provides access to low-level records, then the interface must not be able to subvert the system and bypass security and integrity constraints. The non-subversion rule is that is has an interface that provides access to low-level records. The database dictionary contains the different type of data, and that will be a low-level data, low-level records, high-level records. There is an interface which allows to access the low-level records. Then the interface must not able to subvert the system and bypass security and integrity. Means when you access the low level records, that may be subvert the system and bypass the security. Security aspect may be affected, but in subversion rule, which does not allow to bypass your security and integrity constraint. These are the course rule. Thank you. If any doubt, please ask me. If any doubt, please ask me. Hello. If any doubt, please ask me. No doubts? Hello. No doubts? Hello. Okay, please share your mail ID. Please give your mail ID. I will send all the notes. Mention your mail ID in chat box. Please mention your mail ID in chat box. Okay, wait 1 minute. Please again mention your mail ID. Mention your mail ID again. Okay, thank you.